Hey guys, sorry I can't be with y'all today, but today you're going to be learning about a new property of exponents. We're going to learn two today because they're both very simple, the negative exponent property and the zero exponent property. So let's look at the exploration. So first thing we're going to do is expand. The expression that we have is x to the 4 divided by x to the 5. So that tells me that there should be 4 x's on the top divided by 5 x's on the bottom. Then we're going to see if we can cancel anything out. So looking at this, every time that there's an x on the top and the bottom, we cancel those out. And all that's left is 1x at the bottom. So what we're going to do when we condense this is just 1 over x. Okay, but I want you guys to see what we would get if we were to use the quotient property. So quotient property says that we subtract. So if I had x to the 4 minus 5, that would give me x to the negative 1. So not exactly what we got when we condensed, but there's the pattern. Okay, so let's do another one so we can see it better. Have x to the 3rd, y to the 2nd, over x and then y to the 4. We're going to do the same thing as before. We're going to cancel out any like terms. Okay, and it looks like I'm left with 2 x's on the top and 2 y's on the bottom. So our condensed form would be x squared over y squared. Okay, but what would happen if I use the quotient rule instead? So quotient rule says that we subtract. So for our x's, I would have 3 minus 1. And then for the y's, I would have 2 minus 4, giving me x squared y to the negative 2. So again, it's not exactly what we got when we condensed, but we'll talk about the pattern in a second. Okay, the next one, x cubed over x cubed. So that means 3 x's on top and 3 x's on bottom. So when I go through, literally everything cancels out. So what do you write when everything cancels out? Well, that equals just 1. So any fraction, if I had 5 over 5, if I had 10 over 10, that equals 1. Well, that counts for exponents as well. If I were to use my quotient property, I would have x to the 3 minus 3, which gives me x to the 0. Okay, and then one last exploration to do. X squared y cubed over x squared y to the 4th. Let's cancel out our like terms. And all I'm left with is a y at the bottom, so 1 over y. If I were to use the quotient rule instead, I'll have x to the 2 minus 2 and y to the 3 minus 4. So x to the 0, y to the negative 1. Okay, so now that we've done that, let's actually put some rules to these properties. So a base with a negative exponent must be written as its. So when I say negative, like look right here, I had x to the negative 1, but when I condensed it, it was just x or 1 over x. Here's another time that I had a negative exponent, and that one has to be written at the bottom. So anytime you have a negative exponent, you have to rewrite it as its reciprocal. You're going to flip it. So a to the negative m would become 1 over a to the m. It's positive now. Now that you move it to the denominator, it becomes positive, but only if it's a negative power. The zero exponent property says that a base with a 0 exponent is equal to 1. So no matter what, if you have 0 power, it's going to be 1. So see how I have x to the 0, and that was 1? Over here, I had x to the 0, and also I had a 1. Okay, so we're going to do a few examples together. Let's start with this first one. 10b to the 5 over 2b to the 5. So regular numbers, we're going to divide them like normal. But with b, since this is quotient rule, I would have 5 minus 5. So that turns into, well, 10 divided by 2 is 5. And then for b, 5 minus 5 is 0. But the rule that we just learned is anytime we have something to the 0 power, that's just 1. So really for this one, I could just write 5. Next one, this one is product property. That means we're going to add our exponents. So g to the 3 plus negative 5 and h to the 7 plus 2. So 3 plus negative 5, that's like subtracting. So that gives me negative 2 and then h to the 9. Anytime we have a negative exponent, that needs to move to the denominator. So h9 is going to stay the same, but g squared has to go to the bottom. Okay, next one, again, it's product property, so we're going to be adding our exponents. So starting with our normal numbers, we have 2 times 3. And then with the x's, we're adding, so 2 plus 6, y to the 3 plus negative 2, and z, invisible 1, 1 plus negative 4. So all of that comes out to 6, x to the 8, y to the 1, z to the negative 3. Okay, so a few things. If it's to the 1 power, we don't need to write that power anymore. But if it's a negative power, that moves to the denominator. So our real answer should be 6x to the 8y over z to the 3rd power. The one with the negative exponent goes to the bottom. And last example, this is quotient property, so we're going to subtract m to the 7 minus 9, p to the 3 minus 3. That gives us m to the negative 2 and p to the 0. So anything to the 0 power just equals 1, so I'm not going to write it anymore. And then that negative exponent just means that we write it in the bottom of our fraction. Okay, so those are the practice problems. Okay, on the back of your notes, you have a few questions that I want you guys to work on. They're easier than the ones that we just did right now, so I think those questions are going to go fast. And then after you're done with that, there is a link to a quizzes on Schoology. Make sure that you practice those quizzes problems. All right, bye guys.